Okay, now I want to run through some basic example of using Git command line tool, and there will be some new features that I haven't mentioned previously. And the strategy would be for me to go through a use case, and whenever I will use a new command, I'll also explain what it does and where it might be useful. And without any more words, let's start. And first, a quick remark here: I'm using Git command line tool, but I think that everything that I will show here is also possible with any other application like GitHub Desktop or various other UI-based Git applications. I just stick with Git because it's more comfortable for me to use this way. So anyway, let's start. First of all, let's create our repository, a directory for the repository. It will be, let's name it repo. I'm going to cd into it. It's our empty folder, and previously in previous part when I created a repository, it was also empty when I initialized it. Maybe let's add several files before we initialize it, just to see what gonna happen in this case. So vim first, no, let's name it before init.txt. This file is created before git repo initialized, something like that. We don't have any repository as you can see. We can check it with git status command. And let's now initialize our repository with git init. The repository is initialized, and git status will show us that we are on a master branch. We don't have any commits, and we have one untracked file. So our file that we created before the initialization, this is the same as if we create file right now. So we just will be added to untracked files. So let's commit this file. Let's add this file first. Commit. Add pre-init file, and here we have an error that I didn't have previously. It happened before because before I started this video, I manually unset my configuration, so Git doesn't know who I am, and usually it wants to know it to add this information to each commit I'm doing for future reference. For example, someone else visit my repository and wants to know the author of specific commit, so it shows so it looks into the history log, history list, and tries to find the author there. But in my case, I don't have any information about myself in global config. So so Git asks me to actually save something to it. So let's follow this advice and add our information. Git config ---- global to set it globally, or we can skip this option to set it only to this repository, but let's set it globally. User email, I'm going to pass my real email here, but no, actually there could be any text in this field, and even invalid email.com is a valid option here. Git won't send any verification or something like that to this email. but generally it's a good practice to type your real email for other people to be able to contact you if something happened. So this is about email, and also let me type my name here. Okay, now if we repeat failed command, now it's successfully completed. We don't have any changes, and we have one commit here. And as you can see, we have this plain text field here, author, with config options that we just specified. So this is about the config feature. The next thing is that I want to show you is a difference feature. Basically shows the difference between what you just changed and the state of your repository. To show you this, let's change our file. No, actually, let's create another file. First file.txt. First file after the repository init. We add this file. We have this file as untracked. On other words, it also called unstaged file. Unstaged meaning it won't be added to commit if we now type commit -m something, because it's not staged yet. And to see exactly what changes we just made that are in unstaged state, we type git diff command. And okay, git diff won't show us anything here because this is kind of limitation of Git. Git doesn't actually track files that aren't yet known to repository, and yeah, and to make it trackable, you need to type this command git add first file.txt. Okay, let's actually commit this file to make it simple here. Git commit -m add first file. And what I actually want to show you is, if you modify this file now, add new line, and now Git actually knows that we track this file, and now it's in unstaged state. And to see the difference between unstaged state and our repository state, we type git diff, and we can provide a file name or a folder path to specify some range of files, or just leave it empty, and it will show you the difference of all the files that are in unstaged state. So it's convenient to see what exactly you will add to staged state, and this is for unstaged files, unstaged changes. And there is this command git diff --staged to do the same operation only on staged files. We don't have any staged files yet, so it won't show us anything. Let's move our file to staged state by git add dot. Now it's green. Green means staged, red means unstaged. And now if we type git diff without this flag staged, we will see nothing, because we already don't have anything in unstaged state. And if we specify staged flag, we'll see our one line change. So this is it about diff command. And now let's move to committing a file. Some new features of actually committing a file that helps us to speed up the process of committing. we have this file in stage state. We want to commit it. Usually we do it like so. We type git commit -m and something goes here. We could skip the -m option, and this way we will appear in editor. And in this editor we could type anything, any string here, and everything after these hashes syllables will be ignored. So you can remove it, you can skip it, you can leave it here, it will be ignored. You just type a message here like message created. It's called -i interactive mode. Interactive in interactive mode. You save it, you close the file, and Git will generate the message, the commit for you that has this message as a description for the commit. Its status, you don't have anything in staged or unstaged state, and in git log we have this new file that was created just now. Also, for example, let's add some other another change. Let's add two changes. First change, save first file. Second change. Right, we have two new changes, and we know that we want to add everything, every change in our commits, and we don't want, maybe we don't want to type something like git add before init first. We don't want to do that, and for some reason we don't want to do that. Maybe we have several nested folders, or we are in child folder and want to add everything, even though everything ends even from the parent folder. I don't know there are a lot of reasons, but what about if we want to actually in case we want to add everything, there we can skip git add and go straight to git commit and specify -a option here, or we can type all. This is similar. This is just shortcut. -a is a shortcut, and it will not only create a message for us, but also add everything beforehand. So every file that's in unstaged state will be added to staged at first, and then commit will be applied to the repository. So we type -a and then simply specify the message, or skip the message and specify message over here. Add multiple files in one step, avoiding git add command. Here we don't have anything in unstaged or staged state. In Git we have a new commit. So this way you can speed up a little bit the process of committing, but usually I don't use this feature. It's just there, I know about it. Next, let's move on to git log command. You see we have the list of commits over here, and there is an option to also see the changes that were made during each of these commits. It's done by providing this flag patch, or shortened version is -p, and this is very useful and I use it all the time. if you type if you press enter, you see the same list, but also additionally you have information of what exactly was added or removed or changed during specific commit. And this feature is very useful. So that's it for log for now. And the next thing I want to talk about is branch. And what is branch system in Git? Because previously I haven't mentioned why we use it. If you type git status, you see this, that we are on master branch. Master means, well, basically branch is like a history line of your repository, and master means the main and the only one actually here. If you want to change your repository, but you also want to have ability to return to previous and to main state of your repository, you can separate the main history line and secondary history line. So you will be able to change the second history line, and it won't affect the main history. And you basically imagine a tree. You have branches, right? And you fork. You have places where branches forked into two different directions. And this is the same with repository. You have a main branch over here. You make a fork with before git branch will show you all the branches that you have here. We have only one for now, and command like git branch and the branch name. For example, we want to add a new feature, right? But we don't want to apply it straight away to the master because it could be buggy. It couldn't work, for example, or maybe we just want to test it without adding to the main branch. So we do like, first we create a branch with git branch, let's call it feature. No, let's call it new feature. Press enter. Now we have a second branch, and to switch, and currently we are on a master branch, and git log will show us the history of the master branch from the very first commit to the last one. And if we switch to the second branch, the command is actually git switch feature. Oh no, not a feature, but new feature. Git log. It will also show us the same history because we haven't yet changed anything. We haven't added whatever we want to test in this, whatever feature it is. Let's add let's add one commit here, and it will only be applied to this branch, and then we'll be able to check it by switching back and looking at the history, and we won't see this change in file system as well. So let's create a new file, for instance, and let's call it new feature txt, code to implement a new feature. Here's our untracked files. Let's use previously discovered feature to add actually we need to add this file because it's untracked. And for let's change this file one more time. New line, just to utilize the feature that we just discovered. Git commit -a to add everything here, and the commit will be called new feature. Let's call it add new feature, right? Commit exit, save exit, and our new feature is committed. We have a new commit here, and as you can see, each commit, these two commits, they are pointing to different branches now. Previously they were pointing to the same. I mean, we have two tags here, master and new feature, pointed to the same commit. Now they point to different commits. And here's another tag called head, and head basically points to whatever commit is currently the latest commit of current branch. We are now on new feature branch. It means that head will point to this commit. And if we now switch to master branch, the head will point to this commit. So basically head will point to whatever commit is the latest on the current branch. So now we are on feature branch, and if we take a look at the file system, we have a file that we just created. Let's check it on our master branch. I think that there won't be any, but let's check it. Master. We are on the master. In log we have, you see, we don't have this message. Don't have this new commit because master doesn't know anything about a new feature yet. So there is no commit that we just committed on the feature on the feature branch, and we don't have this file on in the directory as well. So this is why we use features. We could continue working on the files in master branch, and we don't care really about this new feature, and we could continue working on the master, and new feature branch won't affect us in any case, in any way. But maybe there is a time when we want to pull all the changes that we've done on the new feature branch to the master. Maybe the feature is finished. Let's simulate it by first switching to new feature, and maybe change this file one more time. Feature is finished, right? Committing it. New feature is finished. Okay, we have now two changes made on this branch that are not visible on the master. And now switching back to the master. And now I want to show you the way how you can compare branches and really any commits with each other to understand what exactly you will pull, what changes you will merge. And to do that, you use git log command, and you specify the range of commits that you want to compare. For instance, in this case, we first specify the master branch as the base for comparison, then we type two dots, or you may refer to it as a range character, and then we specify whatever branch we want to compare it to. So basically this is like master and our branch that we want to pull to the master. And here we have two commits as as expected as we saw in this command. And this form will only show the difference between the branches. And actually there is another form of git log. You can type git log master. This will show you all the commits on the master branch. And from the very first commit, if you scroll, here's our first commit until the last one. And if you type git log new feature, you will see the same information for the new feature branch, from the very first commit to the very last commit, right? And if you type git commit git log master new feature, what it basically does is it takes a list of commits from this branch, right? It takes all these commits, then it will take all the commits from the second parameter, and it will compute the difference between these lists and only show you the difference. The difference is these two commits, so it will show you only these two commits. And this is how git diff with the range parameter works. And there is another range operator, and it's a little bit different, and it looks like so: git log master, and instead of 2 dots, you type 3 dots, and you type branch name. And in this case, it shows exactly the same as previously, but what 3 dots does is a little bit different. You see, we forked our new feature branch from some commit on master, and we haven't yet committed anything new to master. But if we would commit anything new, let's actually commit some new file to the master branch. We now located on the master. Let's create a new file on master.txt. This is a new file on the master branch that does not exist on the new feature branch, because it doesn't exist on the new feature because new feature was forked from the previous commit, not from this one. Actually, first let's set this file and commit it. Add file that only exists on master branch, right? And if we take a look at git log master now, you see that we forked our new feature from this commit, right? Git log new feature, here it is. But master not on this commit. Master had another commit, and this new commit isn't visible from git log new feature, because new feature doesn't have this change that we just created. So now what git log master new feature show is exactly the same. We have 2 commits here, because git log and range with 2 dot syllables operation will show you the difference. As I explained, it will take the log new feature, it will take all these commits and subtract whatever list of commits of the branch that new feature was forked from. So it will show only the difference. This is a commit where new feature was forked from, and this is two commits that was done only specifically to new feature branch. So if you use two dot range, you'll see only these two commits. However, if you type git log master 3 dot characters and then new feature, you will see 3 commits, because what 3 dots does, it will take git log master all these commits and subtract git log new features, right? And it will only leave commits that are unique between these two lists. And we have 3 unique commits. 2 was made in feature branch, namely these 2, and 1 unique commit from this list that we just created on the master branch. So this is the difference between 2 and 3 dots in git log if you compare between 2 different commits. And basically you are not limited to type the branch names. You could go with git head dot new feature, right? Or 3 dots. In this case this is equal to master, because head and master points to the same commit. You can actually specify a commit identifier, like so, new feature, because now we don't have any output, because I took exactly the commit, and which is equal to the branch. Let's take, for example, this commit, git log. Now we should see a single commit. Here we go. So this is how git log works if we specify the range of whatever we want, either it's a branch name or a commit identifier or another pointer like head or other. We have head -1, which means that it one commit older than the latest one, like -5 commits older than latest commit, and so forth. So this is a log and how to see the difference between branches, and you usually do it before you merge branches, because now we have our master branch. And we are now on the master branch. We have a new file, a new feature branch. You want to merge both of these branches. For that you use, and merge means just connect changes from one branch and to the next branch. You finished your new feature, you want it to be on the master branch. So you type git merge, you completed it, you tested it, and it's all ready to be on our master branch. So you type merge, located, we should be on the master branch, and everything will be applied to master branch, or to any branch that we are currently on. In our case it's master branch. We type git merge and the name of the branch that we want to take all the commits from and to apply to the current branch. In our case it's a new feature branch. We type enter. Here we could type the commit. I'm fine with this name, with default name. Save this file, and that's it. Now if if we take a look at our file system, we have our new file on master, and here's our new feature file with all the changes that we applied to new feature branch. But we are now on master branch, and this is how merge works. And another quick case of merge, there could be the situation where you have a conflict. A conflict is basically when you create a file, create some change on another branch, and you also change this file on the main branch, and this change was applied to the same line, for instance, and when you merge, Git cannot understand what exactly you want to do with this line that you changed in both places. Either you want to apply both of these changes, or maybe some of one of two. Let me show you how it is. Let's switch to the new feature branch, and now maybe we want to modify a new feature, or vim new feature, and we want to modify the first line, updated from new feature branch, right? We commit the file, we type new feature is updated from the new feature branch. Now we go to our master branch, and we modify the same file, and now we change it to something unique to master branch, updated from master branch, right? We commit in it. New feature is changed from the master branch, and now if we make a merge right now, merge new feature, we'll see that we have one conflict and it wasn't automatically merged. If we take a look at git status, we have this message that both of our commits have some modifications to this file, and we want to first resolve the file, resolve the conflict, or we actually could abort our merge, and in case of abort, we'll just undo this step. And if we want to manually resolve the conflict, and this is actually the only way, we need to open the file in any editor, and we have this structure here that wasn't presented. It was added with by Git automatically, just to show us what was in the master branch, also known as head, because we currently on the master branch, and what was added from the new feature branch, and we want to somehow modify it. For instance, we remove all the markers, and maybe we just want both of the changes in the file, or maybe only a single line, or maybe we don't want any changes at all. Let's save both of them. Now nothing changed here, but it said here that after you resolve the file, you just add it. You just simply add this file, and it's staged. Now we just commit it. Here's auto-generated message for us that branch new feature was merged. We save it. and now we have this new feature file with the content that we just resolved from the conflict. So okay, this is about to be it. This is about to be what I was expecting to talk today. The only thing left is to remove our branch, because we don't need it anymore. Maybe we finished with our new feature. Now we want to remove it. We could leave it as it is, but maybe it will be much cleaner if you have only a single branch. So there is this command git branch -d or delete new feature. The only, well, here's one remark. There is another flag called D, capital D, and the difference is that if you have any commits that's in the new feature branch, and at the same time you haven't merged the branches, so it means that if a new feature has some commits that are not in the master branch and you still want to remove a new feature, you use a capital D. It means that so you're basically saying that you don't need these commits, you don't care about them, just remove all the commits. You don't want to deal with them anymore, so you use D. If you use lowercase d and you have some changes from new feature that wasn't merged to master, you won't be able to do it, and Git will show you that there is something that not yet committed to master. Maybe you want to merge it first. So if you don't, you just use capital D. If you don't have any additional commits in a new feature that wasn't yet committed to master, wasn't yet merged, you use D. And okay, and we need to specify also the name of the branch, and here we removed it, and git branch will show only a single branch here. So that's it for today. I showed you today. I showed you how to config the information about the author, some feature of diff command to show the difference, config, also commit shortcuts, and several log operations. Also, I show you how to work with branches, what branch is. We created a new feature branch. We had some unique commits to a new feature. We merged it with master. We also resolved conflict, removed a page. And basically what I'm talking about here, you could also check at official manual of Git, and you can find this manual by typing not a Git but man 7 Git tutorial. And what we discussed today is basically from the very beginning to managing branches, and okay, to here. And in the next video I will start to talk about collaboration, how you can manage your repository if you have several people working on it. We'll talk about cloning repository, about remote origins, etc. There are a lot of interesting information over here, and yeah, you can follow along or you can read this manual. This is very good written manual. But anyway, till next time, bye.